In this problem, a hollow cast iron cylinder of 4 meter long, 300 mm outer diameter and thickness of metal 50 mm is subjected to a central load on top when standing straight. The stress produced is 75,000 kilonewton meter square. Assume Young's modulus of the cast iron as 1.5 into 10 to the power of 8 kilonewton per meter square and find the following. First one is magnitude of the load, which is P. Second one, longitudinal strain produced. Third one is total decrease in length delta. So the given data are the given length L equal to 4 meter, it is 4000 mm. Outer dia is 300 mm. So we have circular hollow and we have the outer diameter. This is outer diameter. Outer diameter is 300 mm. Thickness of the tube is 50 mm. It means the thickness is 50 mm, right? And inner diameter, so outer diameter minus 2 times of thickness. So we have here one thickness, so they are given the entire outer diameter. We need the inner diameter value. So this is T and this is T. So we need to minus this 2 times of T and then we will get 2 times of inner diameter. So we have outer diameter is 300 mm minus 2 times of thickness is 50. So we have 200 mm. So we identified. So inner diameter is 200 mm. Okay. So then we need to solve. To solve cross sectional area. Cross sectional area of hollow bar. As we know, the area of this hollow cylinder or hollow cross sectional area pi by 4 d square. So we have two different d's. One is outer diameter square minus inner diameter square. So the area will be pi by 4 300 square minus 200 square. So we have pi by 4 into 300 minus 200 square. So we have pi by 4. What is 300 square? 300 square minus 200 square. We got 500 and 00. So we have to multiply with pi and to pi by 4 into 5000. So we will have, so pi we have into 5000, 50,000 is equal to divided by 4. Then we have 39269.90. This is a area. It means area means mm square. So we find out the area. Then we'll go for normal stress. Normal stress developed in the hollow shaft. So what is normal stress? The given values are 75,000 kilonewton per meter square. So we will change this as in terms of millimeter square. So we will change this as, go with 75,000 into 10 to the power of 3. We will change kilo into 10 to the power of 3 into Newton divided by, we will change meter into mm square, that's we will multiply with 1000 into mm square. So we have the whole square. This is whole square. Why? Because mm into whole square. So this is 10 to the power of 6. So we will cancel. We will rearrange this equation as 75. This 3 into 10 to the power of 6 Newton by this square 10 to the power of 6 into mm square. So this will cancel. So stress is 75 Newton per mm square. We change it as mm square. So the normal stress due to develop they are given, and the load, right? Then we'll go for the load. So stress will be load by area, or we can write as load equal to stress into area. So we know what is the stress. We generate 75 Newton per meter square mm square into area. We find out that when we have to multiply for finding a load equal to stress 75 Newton per mm square unit output into 39269.908 mm square. So this will cancel, mm square unit will cancel, and you have to multiply, right? We have to multiply with 39269.908 into 75. That will get 294,5243.1 kilo. It means Newton. We have already this in Newton, so we can write it as, so this we have to change is kilo Newton. So we will write 10 to the power of 294. So we have to come here 5.24 kilo Newton. We change this as a kilo Newton, right? Load we have got. Next, normal strain we need to find out. Second one. Second one will find normal strain. Strain will be change in length by original length. We can also write it as strain equal to stress by Young's modulus. Strain equal to stress by Young's modulus. So we have, what is the strain we have, where the given value is 5 into 10 to the power of minus 4. So we'll apply E equal, they given the E value, first we'll the given data as E equal to 1.5 into 10 to the power of 8 kilo Newton per meter square. That we have to rearrange into mm square. That we will get 1.5 10 to the power of 5 Newton per mm square. mm square, right? That we will get in kilo Newton per. So it is E 2 per square. This kilo, and if you multiply that, then it will come in the square. So we have strain equal to L into E. So from this equation we got this value, we have this value, we have to find out the change in length. So change in length will be strain into L. Before that we have to find out the strain. Strain will be 5 into 10 to the power of minus 4. If you multiply or if you divided load by strain, what is the load? What is strain value? 75 Newton per mm square divided by, if you put E value 1.5 into 10 to the power of minus 5, you will get what value you will get? 5 into 10 to the power of minus 4. 5 into 10 to the power of minus 4 strain you got. So deflection, change in length will be 500 into 10 to the power of minus 6 into 500. So we will rearrange this as 500 into 10 to the power minus 6. So I will call it 500 micro strain. This is the 10 to the power micro strain. So we will put micro strain into 4 meter. That if you multiply and if you get 4 into 220 into minus 3, then we will get 2 into 10 to the power minus 3 meter in terms of meter. If you convert it, this is equal to 2 mm. So deflection will be in 2 mm. So we identified this third one as deflection. We identify in the results. What we identified? One as load. One is load. P equal to 2945.24 kilonewton. And second one is normal strain. Strain will be 500 micro strain. And third one is what is it? Third one is decreasing in length. Decrease in length. That is delta. That is 2 mm. Right? So we'll do the revising of this problem. So they are given hollow cast iron. The Young's modulus of 1.5 10 to the power 8 kilonewton meters by meter square. So we identify load, strain, and decreasing length delta. So we have to draw. We have to from the given data we have to take length L. Outer diameter they are given. Thickness of the tube they are given. From the inner diameter, so we need to find out the inner diameter. Outer diameter minus 2 times. Why? Because you have the entire diameter is outer diameter. You need to find out the inner diameter. These are inner diameter. So you need to minus 2 outer thickness. So you will get inner diameter. So to find out this, the cross sectional area of hollow bar, cross sectional area. So only we are finding this value, this area, only the thickness of the material. So we are taking pi by d, pi by 4, d square minus small d square. This is outer diameter minus inner diameter. So we are getting a value 39269.908 mm square. So normal stress developed will load by the given data is we are changing into Newton per mm. Then we will go for the stress value. In that we will finding the load equal to 2945.24 kilonewton. So normal strain will be changing the original length, or we can write this as Hooke's law, stress by Young's modulus. So stress by Young's modulus we will put getting this 500 10 to the power minus 6. It means we are changing this unit we know micro, so we are putting this. And E equal to 1.5 10 to the power 5 Newton per mm square. We are changing this as kilonewton to meters into kilonewton to meter square. So mm square. So deflection equal to strain into original length. Strain we have, original length we are getting. The decreasing length is 2 mm. So these are load, strain, and decreasing length values. Thank you.